Hello everybody. Today we're going to take a look at Unit 0, Lesson 3, Vertical and Horizontal Lines. So a short lesson today, and we've touched on vertical and horizontal lines a little bit earlier on in the unit, but we're just going to, again, take a look at what do the coordinates look like for vertical and horizontal lines. If we're looking at a table of values, how does that then translate to a vertical or a horizontal line? So if we look at these tables of values, we're going to determine the equation of the line based on them. And we're going to draw a little sketch just to kind of help us see what these really look like. So we have a table of values. I'm just going to draw a rough sketch here. The first point is at 0, -3. So we'll say -3 is like somewhere here. And then 2, -3, 4, -3, and 6, -3. So hopefully you can see how this is shaping up here with the points we have, right? We're going to have a horizontal line. So when all of our y values were a certain number, it resulted in us having a horizontal line. So we can see that in this case, all of our y values were equal to -3. So our equation of our horizontal line is always going to be y is equal to some number because all of the coordinates have a y value that are the same. So if we were to identify the slope of a horizontal line, we've talked about this before, but it's 0, right? There is no rise in this line at all. There is a run to it, but 0 divided by anything is going to be 0. And the equation for a horizontal line, the way we write it, like the generic form, is going to be y equals b. So it's going to be y equals some number. That number is going to be whatever is our y values for all of our coordinates on that line. Okay, let's look at a table of values now, where we're going to end up with a vertical line. So now we have a table, and it says our first coordinate is 2, 3. So 1, 2, 1, 2, 3. And then our next coordinate is 2, 4, 2, 5, and 2, 6. So again, I'm just going to connect those dots. Just get my ruler in place. Make sure you always have your ruler so you have a nice straight line. Okay, and you can see that in this case, where all of our x values are exactly the same, we ended up with a vertical line. So if we were going to write the equation for this, because what's consistent is that our x value is always equal to 2, that's the equation for a vertical line. So x is equal to 2. The slope of a vertical line, as we've talked about before, is it's too steep, really, to measure the steepness. So it is undefined. And if we looked at this in terms of rise over run, again, there is a rise, so we do have a top part of our slope, but the run is 0. So you can't divide something by 0 because that is undefined. The equation for a vertical line is always going to be x equals some value, or a. Right? So let's try to write an equation knowing what we know now about horizontal lines. Okay, it says write the equation of the line that is a horizontal line. So we know, I'm just going to highlight here, that if we have horizontal lines, we're going to have an equation that's y equals something, right? And it's going to be the y value of whatever that point is. So in this case, we're going to have y equals, and if you think of our coordinate almost as like a and b, like we have in our equations above, this is going to be y equals -2. Okay, the next one says is a vertical line, so we're just going to highlight, okay, we know we have a vertical line, and a vertical line is always x equals a. So a vertical line and is located 6 units right of the y-axis. So that's a lot of information. We'll just draw it. So here's our x and y-axis. Okay, and it's going to be 6 units to the right. This is my y-axis, this is my x. So we'll just say, okay, we're going to have some vertical line. It's going to be 6 units this way. So it's going to be some vertical line that does this, right? So if it's 6 units to the right of the x-axis, I know, for example, that I can pick any point here. Let's say this is like 6, -2, right? This is like 6, 4. Okay, so again, all my x values are going to be 6. So the equation for this is x equals 6. Okay. The next one is looking at a shape. Now knowing what we know about vertical lines and horizontal lines, we can easily come up with the slopes of those lines. But we have a third side to this triangle that does have some steepness to it. And we've talked about and come up with strategies for determining the equation of those lines as well. So it says determine the equation of the lines that form the edges of each shape. So I'm gonna number these edges. We'll call this 1, and I'll put a different color on all of them. We'll say this is 2, and this side will be 3. Okay, so let's start with side 1. All right, we have a vertical line. Okay, so we know a vertical line is going to be x equals something. It's going to be whatever x value it's crossing. So it looks like we're always at -3 for all those, right? So 1, 2, 3, right? We're always going -3 and then up or down some value. So it's going to be x equals -3. Side 2, we have a horizontal line. So if we have a horizontal line, we know it's going to be y equals something. Okay, and again, we just have to look and see, okay, what's my y values on this line? It looks like it's 1, 2 down, a -2 down. And it's -2 for every point on that line. So y equals -2. Okay. Now for side 3, we're going to have to do a little bit more work. Right, we have a line that has a slope, has some steepness to it, so we need to identify our y-intercept and our slope, and then plug it into the equation. So we will start with our y-intercept. So our y-intercept, I'm just going to move this over a little bit. So this is 3. So here's my y-intercept here. So my y-intercept looks like it's at 0, 2. So my b value is 2. And then if we were to figure out our slope, we can take any 2 points on the line, keeping in mind what the equation of those other lines were. You might be able to find out some information. So let's say, I think I'm going to move that one more time out of my way. Put it up here. We'll pick the y-intercept point we already had, and we'll say this point as well. So it looks like we're going down 2 over 3. So down 2 over 3. So my slope is a -2, 3. Okay, so once we have our slope, once we have our y-intercept, we can write the equation of that line in y equals mx plus b. So remember, y equals mx plus b. You have y equals -2/3 x plus 2. And hopefully you can see some similarities. The equation of our vertical line was -3. The equation of our horizontal was -2. You can see that those numbers kind of come up again when we look at the slope of our third line, which should make sense because really we could have used the endpoints of that line to determine the slope, and that's just made up of the horizontal and vertical line. So it should make sense that 2 and 3 come into play when we're measuring the slope of that diagonal line. Last part is we're going to graph each of the following lines, keeping in mind what we know are the equations for each of these types. So that first one says x equals -3. Well, if we have x equals, we know we have a vertical line. So we're going to have a vertical line at -3. I'm just going to draw with, you should always use your ruler, but -3. Okay, the next one says y equals -2, so we know we have a horizontal because it's y equals. And again, that's going to be at -2. So I'm going to find -2 that's down here, and we're going to draw a horizontal line. Okay, and then we have x equals 0 for that last one. So again, if it's x equals, it's going to be vertical. And we're going to put it right at 0. And we're going to draw our straight line. All right, so we've talked about vertical and horizontal lines today. Remember, a horizontal line is always y equals whatever the y value is, and a vertical line is always x equals whatever all the x values are as well. Okay, then you should be able to hopefully translate that. If you have the equation, you know if it's vertical or horizontal, where it's going to cross. That's all for your lesson for today.